Hello, thank you for joining us. Today, I will be talking about my team's Raspberry Pi Sensat visual email notification system that we have built. Our group consists of Mahmoud, Emil, Abdullah, and Nurusin. Now let's look at a high-level overview of our Sensat email notification viewer application. Now, first thing is our IMAP server will connect to the Raspberry Pi 3 to connect to our Gmail servers. Now, the Sensat board will be used to show the statuses of our messages. When the IMAP is first booted up and starts, the Sensat will, on its 8x8 LED, will show two type of indicators, X or a check mark. X will be shown if the configuration has not been loaded correctly and there's an error, and the check mark will be shown if everything is successful with no errors. Now, on the Sensat itself, we will see different types of indicators on the 8x8 LED to show the status of our emails. If we have 15 unread emails, there will be a red indicator. If we have a yellow indicator, that means there's 1 to 14 emails unread. And with the green indicator, there means only one email has been read. A happy face means there's no emails, and a sad face means checking the mailbox icon. Alright, so now we'll be looking at the system designs. The first system design is a use case diagram. Now, the use case diagram will show what happens when the user first runs the Raspberry Pi. What happens in the beginning is the Raspberry Pi will send a request to the Sensat to display the hello message. Afterwards, it will try to log in, and if the login is successful, it will then check how many new emails are in the email inbox and display the number of new emails on the Sensat. Now let's look at the next system design, which is the UML diagram. The UML diagram shows more relationships about how our classes are interacting with each other within our system. The first email notification system is the first main class, which is the actual application. It requires some variables and functions in order to connect to the IMAP server. And the IMAP class is responsible for creating the connection between the external IMAP service. More so, the time class is used as part of calculating the current time and the delay between email checks. As we further looked into it, another class, which is the Sensat class, is used to send and receive data from the Sensat, which functions in this email notification system to display and update number of emails, as well as display the images sent from the email notification. Last class is the system standard out, which is used for the email notification system to display messages on the user's terminal. Now, let's look at our state chart diagram. The state chart diagram demonstrates the details of how the application changes the states of the visual email notification system. The displayed image is based on the number of new emails. So, the email check is run recursively. The time between each check is based on the specified delay time on the configuration variables. Every time the visual email notification system checks the email, it updates the displayed image in the Sensat board based on the number of unread emails when the system checked. The sequence diagram shows one. The last system design is the sequence diagram. The sequence diagram shows one case when the user is successfully able to log in and how it's able to use the system connection between the user. The Raspberry Pi, Sensat, and mail server is in order to display the notification on the Sensat. As you can see, the user will start the Pi. The image will be loaded onto the SenseHat if the login is successful. However, if the login is not successful, then there will be a continuous recursive process until the user is successful. Next, we will use the check number of emails to query the mail server for the number of unread emails. That information will be transferred back to the Raspberry Pi, and we will get an indicator on the SenseHat to display image based on number of emails there exist. Now we will start discussing the security threat modeling of the email notification viewer. Unfortunately, our current system does have some security vulnerabilities. One of them is the physical access attack scenario, and the second is the buffer overflow attack scenario, which we'll be discussing. Currently, there exists a lack of physical security, which can take down our entire email notification system. Since there is no physical barrier surrounding the Raspberry Pi, it is vulnerable for any malicious user to physically terminate the power source. Not to mention, it's also vulnerable from having the SD card ejected from the Raspberry Pi. Since the operating system and all dependencies for the email notification are on this portable medium, the Pi cannot function without it, and the SenseHat is unusable. In addition, the login information is stored in plain text of the SD card, which an attacker can read the information and compromise the email address. Now, a potential method to alleviate this potential threat and attack scenario is implementing a physical barrier around the Raspberry Pi device to ensure the power source and the storage medium is not removed from the email notification system. The physical barrier can be implemented by using a specialized case to protect the Raspberry Pi. This is very similar to server racks that are found in data centers, which are confined in locked cases. Now please note, the case will also protect the SenseHat as well with the Raspberry Pi device. The case will block any individual from unplugging the power adapter and ejecting the SD card. The physical barrier is a metal confinement to prevent malicious users and individuals from attacking and forcefully breaking the case. The only way to physically gain access to the system is by unlocking it and by utilizing a specialized key. The key should be distributed only to authorized users, for example, Raspberry Pi administrators and hardware maintenance teams. Looking into a security threat modeling diagram, as you can see, the vulnerable application obviously exists on the Raspberry Pi and SenseHat. Now, a remote user or an attacker in the building can physically cause harm to the system. For example, of course, an attacker who's physically present in the building itself can damage the hardware, or they can manipulate the applications and the SD card running the operating system in a way where backdoors are created. Then a remote user would be able to attack by leveraging the root access. We see that our web browser is connected directly with the web server and the mail server. This is done using a TCP connection. We will assume a SSL connection has been utilized for this type of communication to ensure encrypted channels are created. Now, looking at a buffer overflow attack, this type of attack could be used in an example where a user receives a notification from the system as the symbols are made on the SenseHat lights. If the user chooses to connect the Raspberry Pi to a screen to configure it easier and have a graphical interface to read and receive emails, he or she is in the risk of security of the system because some emails might not be infected and meant not harm to the system. With the buffer overflow program downloaded on the Pi, the user will not notice any changes and will not get any suspicious will not get suspicious about the system performance because it is not harmful until it has been exploited. If the attacker exploits the vulnerability and succeeds, he or she will gain access to root user to the system, where the status messages can be faked, emails are stolen, and passwords are changed. A solution to this potential buffer overflow attack is to avoid this kind of attacks by not opening any emails on the Raspberry Pi at all, and not installing any foreign applications. Furthermore, the user should check the emails on either the remote location or personal device. However, if the Pi is in some kind of organization where emails are checked, opened, and read on the Pi, there should be security policy to prohibit users from downloading any attachments from an email to an organization's device. Now, our business continuity plan will revolve around 3 critical applications and tools: the Raspberry Pi, the SenseHat, and the email server. Now, as we look at our business continuity program, we first need to form the BC team, the business continuity team. For this project, the business continuity team will consist of 2 IT members, and the work will be related to the email service themselves. And we will also have 1 manager for each given department. Furthermore, we must review the BIA. This will be reviewed by the upper management because they have a better overview of what's happening within their organization and their business operations. Next, we must identify preventative controls. We must do this to provide a physical caging around the Raspberry Pi. We must prevent any malicious users or unauthorized users gaining access to the Raspberry Pi, as it delivers extremely useful business operations and functionalities. Next, and lastly, we must create relocation strategies. We must relocate email servers in a given situation where it's vulnerable to the system. Next, we will develop the BC planning policy statement. The purpose of our policy is to ensure all email servers are operational, even after the email notification device has been compromised. And the scope will consist of the entire organization itself. As we look into the roles and responsibilities of various different individuals surrounding the BC plan, it will have response members. These response members will identify account associated to the devices and be able to temporarily disable the device as well. The IT rollover member is the one who is responsible for rolling over email servers to the backup servers to make sure we have retention on the various different images of the SD card. The manager will notify and talk to the employees and stakeholders of the current situation that is going in our organization as it pertains to the Raspberry Pi's well-being. And lastly, the resource requirements will be, of course, the email servers and the Raspberry Pi device. Now, looking at the training requirements, we have to ensure we have experiences with rollover situations, Linux server state recovery, and we have to ensure our IT admins know how to do this in the case where we need to go back to a previous snapshot and use it to recover the current state of the Raspberry Pi. We also must test the schedule. We have to understand what is the minimum of when we need to implement our rollover mechanisms. Best practices is, of course, during off hours, so we don't affect regular business operations. And last, we must plan the maintenance schedule. We must plan when the maintenance must be done on the servers. For best practices, this would be good to do once a month, at least, to ensure the Raspberry Pi is up to date all the bugs are cleaned up and we have any other security vulnerabilities patched up. Alright, now let's take a look at the disaster recovery strategies. There's two strategies we want to look at: Raspberry Pi compromisation and the email server compromisation. For the Raspberry Pi compromisation, we want to first identify the account associated to the Raspberry Pi in which it was stolen from. We then want to recover the account and change the account credentials to ensure this malicious user does not have access to the Raspberry Pi. And lastly, we want to inform our employees for the situation so they can also keep track of some type of malicious or suspicious activity occurring, and also they can also understand and look at if the application is performing the way it's supposed to. Now, if we look at the email server compromisation, we can identify the other service compromised, and also look at the rollover email and other compromised services to back up the infrastructure. Alright, so now we'll show you the demonstration screenshots we received from the email application notification viewer. Now, the first image is the configuration error icon because it's missing some parameters within the config file that has errors. So the Raspberry Pi will show a cross X in red. Now the second image is a check mark. This configuration means that the errors have been resolved and the connection has been established successfully. And next is the welcome icon, which shows the Raspberry Pi is booting up and is ready to go. Now, furthermore, looking into our application, please note that a new email address was created for this demonstration. Now, if the mailbox is currently empty, there is going to be a happy face presented on the SenseHat, which is represented on the image on the left. When the SenseHat is initially checking for the emails and querying the IMAP server, it will have a neutral face on the SenseHat. Now, as we look into the mailbox, depending on the number of unread emails within the inbox, there's going to be different colors represented on the SenseHat itself. For example, one email in the mailbox will demonstrate a green light. An email in the range of more than 1 but less than 14 unread emails will represent a yellow light. And the red light will be displayed if there are more than 15 unread emails within the inbox. This concludes the end of our presentation. Just to summarize everything, we believe the email notification viewer is a very useful application to help determine the number of unread and read emails within our inbox. Now, although this is an amazing application, there are definitely some security vulnerabilities. However, with the right policies and backup solutions, we can ensure that these vulnerabilities are mitigated, and as well, we have backup solution in case the system is compromised, in which we can roll over to a new solution. No doubt that there needs to be a solid business continuity plan in place to ensure that this process is completed on a day-to-day, week-to-week, and month-to-month basis. This will ensure our application is up to date, policies are upgraded for the current business situations, and we can ensure this application continues to serve the purpose it needs to. Thank you for watching.